In question number 28 on page 80, we're looking at which of the following functions does not have an inverse function. Well, if it doesn't have an inverse function, it means that the inverse does not pass the function test. So going backwards, which is our inverse, it will give us 2x values. Maybe what we could do is algebraically find the inverse and then test it with a vertical line test. However, since inverse, in an inverse, all the horizontal properties become vertical, or all the x properties become y properties, and all the y properties become x properties. We can, instead of using a vertical line test on the inverse, we can actually just apply a horizontal line test on the original function. So taking a look at A is a sine function that's been trimmed. And it's been trimmed from negative pi over 2 to pi over 2. Well, if I trim that function and I apply a horizontal line test to this, well, it passes a horizontal line test. So everywhere on that function, it passes a horizontal line test, which means then that the inverse must pass the vertical line test. So that A is okay. For B, we can look at this as a cubic function. And this cubic function has been vertically shifted up plus 2. And if I test this with a horizontal line test, it passes my horizontal line test everywhere on that graph. So if it passes a horizontal line test, the inverse must pass the vertical line test. Now C is a little bit harder because this is a function that we probably don't know how to graph. And I should state that we don't know how to graph yet. So we're going to learn how to graph these a little bit later. So we want to get familiar with these at some point. But right now, we probably don't know what this looks like. So another strategy then, instead of using a graphical method, is we could just use an algebraic method. And we can find the inverse and see if the inverse is a function. So to do an inverse, we switch x and y's. And we solve for y. So if I'm going to solve for y, I need to get the y squared plus 1 out of the denominator. I recognize that it's a quadratic function in terms of y. So I'm just going to highlight the coefficients I'm going to use. There's my a, there's my b, there's my c value. And I can factor this, I can complete the square, but really I have a quadratic formula that will solve for this quadratic equation. So although my coefficients are not numbers, I can still solve this as a quadratic equation. Now my quadratic equation will not solve a numerical value for y, but it will solve for y and put it into the function form of this relationship. So negative b plus minus the square root of, this is going to be negative, so that's going to be minus y. So negative is going to be positive. Negative 1 squared minus 4 times a, so my x value is a, times c. Well, this c is x as well, so it's going to be times x all over 2a. Now at this point, I can look at this and I know that this is not a function because that plus minus will not allow it to pass the function test. So y is equal to some number plus minus some amount. That's going to give me 2 solutions for y, and that's not going to pass my vertical line test. Each x must give me only one y for it to be a function. This x here, these x's will give me 2 different y's. So this will not pass the function test. And just to finish this off, if I finish this off, I get 1 plus minus square root of 1 minus 4x squared over 2x. So that does not allow me to pass the function test. This is not a function. So C is my answer. I should finish this off and just analyze my graphs for D and E. That is D is an exponential function. So the inverse is a log, and that will pass my horizontal line test, so my log will pass my vertical line test. For E, that's a log. Okay, it's been shifted over +2, so I'll draw my asymptote here. It's been shifted over +2. The inverse is exponential, so that should pass my vertical line test, so my log passes my horizontal line test. Now lastly, before I finish this, is we do really want to start understanding what these graphs look like. So I would like you to make sure that you graph anything. Just look at the graph when you don't know what the graphs look like. We need to start getting familiar with these graphs. So for C, if I were to graph this, there's a couple things here I should look at. First of all, there is no vertical asymptote because there's the denominator is never equal to 0. However, there is a horizontal asymptote. If I do a limit as x goes out to positive and negative infinity, we have a horizontal asymptote at 0. We have a 0, x is 0 when y is 0. We get that from the numerator. And by the nature of this function, this is an odd function because the denominator is always positive. As x goes positive, it's going to go in the positive direction. It's going to go up, and at some point when it's going to start coming back down towards 0. On the negative x, it's going to be going negative, and again, at some point, it's got to come back down towards 0. The graph's going to look something like this, and because of that little bump there, it will not pass the horizontal line test. Therefore, the inverse, which is this one here, the inverse does not pass the vertical line test. So the answer still is C.